Think about how we talk every day. We say things like, I'm trying to find balance, or the situation is spiraling. None of these sound like math, but they all come from mathematical ideas. Somehow, equations and theories don't stay inside textbooks. They escape and become part of how we think. So here's the question. Why does this happen? Why do mathematical theories turn into metaphors? To answer that, we need to understand what math actually does. At its core, mathematics isn't just about numbers, it's about patterns. Math takes complex situations and reduces them into clear patterns. For example, balance, repetition, growth, limits, and change. These patterns show up everywhere, not just in equations, but in real life. And when we recognize the same pattern in life, we borrow the mathematical idea to explain it. Real life is complicated. Emotions are unpredictable, people behave differently, situations don't follow neat rules. But patterns simplify things. They give us a way to make sense of what's happening. Instead of explaining every detail, we say, it's a cycle. It's growing out of control. It's reaching a limit. These are not exact descriptions, they are pattern-based shortcuts. But there's another important step. Math is abstract. It uses symbols like X, Y, and equations. But most people don't think in symbols. We think in images. So when a mathematical idea enters everyday life, it transforms. It becomes something visual. A loop, a balance scale, a chain of falling dominoes. That transformation is what turns math into a metaphor. Take the domino effect. Mathematically, it is a type of chain reaction where each event depends on the one before it. We can describe it simply as this. This formula shows that each step leads directly to the next. But sometimes, the effect doesn't just continue, it spreads. Let's look at this formula. Here, the R tells us how strong the effect is. If R equals 1, the chain continues steadily. If R is greater than 1, the effect grows larger at each step. Well, what does this represent? This connects to exponential growth. So, to explain further, a very small starting point can lead to a very large outcome. Now let's think about another phrase used in daily life. I feel stuck in a loop. In mathematics, this idea comes from recurrence relations, where each step depends on the previous one. A simple version or a simple formula of this is, wait, isn't this the same thing? In this example, we notice that if k is equals 1, nothing changes. If k is greater than 1, the values grow. And if k is lesser than 1, they shrink. But in all cases, the system keeps following the same rule. In real life, this becomes a metaphor. For example, you feel stressed, so you avoid work, which increases stress, and then the cycle repeats. Mathematically, this is similar to a feedback loop, where outputs feed back into inputs. Small changes don't break the system, they just keep reinforcing the same pattern. So when we say I'm stuck in a loop, we are actually describing a system where the present depends on the past. The pattern repeats, and it's hard to escape without changing the rule. So here's the main idea. Mathematical theories become metaphors because they describe universal patterns. Patterns that exist not just in equations but in human life. Think about it. Math studies things like change, repetition, growth, limits, relationships, and these aren't just mathematical ideas, they are also the structure of everyday experience. We experience growth in our habits. We experience limits in our patience. We experience repetition in our routines. We experience change in our lives. So when a mathematical theory captures one of these patterns clearly, it becomes something we can use beyond math. Math is precise. It tells us exactly how something works. But most of the time, we don't need that level of precision, as we saw earlier. We just need to understand the idea. Instead of saying, the system follows a recursive function, we say, I'm stuck in a loop. Instead of describing a sequence of dependent events in detail, we say, it created a domino effect. The metaphor removes the complexity but keeps the meaning. In a way, metaphors are like translations. Math is one language, human experience is another. And metaphor is connecting the two languages. It takes something abstract and technical and turns it into something intuitive and relatable. So when we use mathematical metaphors, we are not simplifying the idea incorrectly. We are actually preserving its core pattern in a form we can understand instantly. That's why math doesn't stay confined to equations, because its patterns are too powerful. They keep reappearing in the way we think, the way we speak, and the way we make sense of the world. This is why mathematical theories don't just remain theories. They become a part of everyday language. They become metaphors. So the next time you hear someone say those same phrases again, remember, they're not just using everyday language. They're using mathematics in disguise. Because sometimes math doesn't just explain the world, it becomes the way we understand it. Thanks for watching.